all for being here today. And my name's Ray. I'm going to talk a little bit about gRPC today. And I'm a developer advocate for the Google Cloud Platform. I actually live in New York, but I grew up in LA. And my primary job is to bring some of our latest and greatest technology that Google has to offer to developers all over the world. But in addition to that, I also like to get your feedback and your experiences in using our technology. At my Twitter handle at Satanism. That is probably having the fastest interrupt to getting my attention, and I will be able to respond to your questions or your feedbacks. And aside from technology, I love to travel. I love to travel everywhere globally for fun and for work. And I like to take photos, and this is one of the photos I took before in northern China, I believe, where I was actually hiking in the desert for 4 hours by myself to find an oasis. Somebody told me I can stay, as a backpacker, I can stay in the oasis for free if I were to just find it in the desert with a compass. And they said you have to walk there by yourself for 4 hours, and so I did. Anyone here hike in the desert before? Anyone? No? There's always a few. By yourself? Yeah? Yeah. It's, I was incredibly young and stupid, so I decided to, okay, just get a bottle of water and let's go. And 2 hours into it, I look back, there's nothing behind me, there's nothing in front of me. It's just that. And when somebody tells you to walk in the desert for 4 hours for a certain direction, you don't just veer off left and right, right? If there's a sand dune, you don't go around it, you go straight over it. Because if you're just off by a degree, I don't know what I'm gonna be after 4 hours. And if you never hike in the desert, it's almost like a walk in the beach, except a lot more, and you just don't see the end. And there are these sand dunes. So every time you take a step in, what happens? Your foot sinks a little bit, and you have to pull yourself out. And it's incredibly hard and difficult. It's hot and humid. And it really just reminded me of writing traditional J2EE apps I'm sorry. But no, seriously, like that's how it was. And eventually, I saw the oasis, and it was beautiful. It was beautiful. It was absolutely incredible view, and I'm happy I got there. And that's kind of how I see what I'm doing for these type of things. Is I want to bring you, all the people in the audience. I want to airdrop you with a helicopter into the oasis, so you don't have to go through all the troubles yourself. And hopefully, you're going to learn a lot about gRPC today, so you can give it a try when you go home as well. And why am I talking about gRPC? Well, first of all, there's this trend of moving towards microservices, right? Or if you're building applications, you build service-oriented applications in the past, right? And we're continuing to do that today. And if you already have a monolith, or if you're trying to build microservices architecture applications, right? One of the things that you're going to realize is that, no, like all of these little components, I'm going to be breaking them down into smaller pieces. But there are consequences. There are going to be costs associated with doing that. The very obvious one is, of course, that there's DevOps. You need to maintain these services. You need to run them, keep them up and running. You need to upgrade them, and maintaining the versions of them, right? Just like a dedicated application. Now you're going to have more of it, right? You have to remember that. There's going to be more of these things that you have to do rather than less. But fortunately, we have tooling to help us to manage the instances of microservices today that we couldn't do before, right? Through containerization, through container orchestration, through the toolings like Kubernetes, now we can actually manage hundreds, thousands of instances of your application. But one of the things that people don't usually think about is how do these services communicate with each other? In many cases, your microservices are going to be running the backend, and they're going to be talking to each other rather than talking from the front end, right? So some requests come in from the front end and goes to the very first backend. And from that backend, it's going to be talking to other services in the backend again. And our default choice has been REST, right? Default choice 10 years ago has been SOAP, right? But we talk about SOAP being too slow and all that. But REST is getting some similar feedback as well. So the thing I wanted to do is to just raise awareness to let you know that we have an option. We have a really good option today to actually do this very efficiently with binary protocol with RPC. RPC, wait a second, that sounds very familiar. I've been doing RPCs many, many years ago. I thought that's not a thing anymore, right? How many people here has done Corba? Yes, do you like it? Yeah, some people do, right? I'll show you a little example as I was preparing for this talk. Like, how did I do core by before? So I found this really good website. It's a really, really good tutorial. Awesome tutorial. If I ever need to do core by again, this is the tutorial I will go to. And I started off reading that, okay, yeah, I remember this. I need an IDL, interface definition language of some sort, because we need a simple language to define our service so that it can be, so we can generate code for other languages. That's what they have done really well before. And then you can generate the stub, of course. And the stub is something you can just inherit or extend. And then you can implement the actual implementation of this service without having to write a lot of boilerplate code. And then I was like, oh, this is great. This is awesome. And then I went down to the client. So how do I code this thing that adds two numbers together? And then that's where I got into trouble. I'm like, oh, no, I remember this now. I got to use an object request broker of some sort. I need to do narrowing and all that. I have no idea what these things do anymore, right? And that's why sometimes RPC has a really bad rep, because it used to be very complicated to do to make it so that it's interoperable. But not only that, we have easier way to do this in Java, right, with RMI. Anyone using RMI today still? Yeah, very good. So I love RMI. The only thing there is that it's not as interoperable, right? You can only deal with Java clients, potentially. But if you only deal with that world, that's perfectly fine. Really easy to do, really easy to write. But remember 10 years ago when people said, wait a second, we need all the services to be interoperable because Java is not the only application running in the environment. So then what did we do? We found the most interoperable standard, which is text, right? Which essentially was XML. And then we created messages around XML. And then we had ways to define the services around that with SOAP and WSDOs and all that. And then I think something happened. People complained about them being so slow, and people moved on. But if you think about it, we're not so far away from where we are 10 years ago. Because now we are dealing with REST. That is still text-based protocol, right? To generate clients, what do? We got rid of the WSDO, but we still are creating Swagger documents, so you can actually have a good definition of what the service looks like, right? So we haven't really done things that much differently. And also, there are things in REST that just you cannot express nicely via REST protocol, because REST is really just CRUD, the get, the put, the patch, right, the deletes. But if you have a business operation that you want to implement, right, it will be something like withdrawal. Well, how do you implement withdrawal operation in REST? You need potentially to patch two different resources. How do you actually do that? Then we can actually hack around this HTTP RESTful protocol to implement operations, right? So why RPC? Well, to me, RPC is efficient because it's binary, and it's strongly typed. It is strongly typed. As Java developer, I need strongly typed things. I don't want to recreate my client every single time. And it can only be great, though, if it's simple to use, right? Extremely simple to use and interoperable across multiple languages. So at Google, we use Stubby. Okay, that's our internal project called Stubby. This is what we use internally for all of our backend services. We make 10 to the 10 RPC requests per second via Stubby in our data centers. This is a mind-blowing number, 10 to the 10. Now, if you just think about this being a text protocol, or just even taking 1 byte more than necessary, that's 10 to the 10 more bytes per second that we have to transfer all over the place, right? So Stubby was made to be very efficient, and that's being used internally at Google. So what happened is, if I recall this correctly, right, another company called Square, they were looking into a new RPC solution. Google was looking to open source RPC or Stubby as well. And so the two companies joined forces to create the gRPC. So this is the open source project that is based on the ideas and the implementations of Stubby from the past. And this is basically the new generation of the RPC framework that is fully open sourced. Now, the trick here is that the G in gRPC does not stand for Google. All right, just remember that. It is actually a recursive acronym. gRPC stands for gRPC Remote Procedural Code Framework. Okay, so it is fully open source. It's on GitHub, and anybody can contribute and part of the reason why I'm here is I want people to help and provide feedback and contribute back to our repository as well. It is simple to use, which we will see in a second. It is designed to be performant and scalable, and also interoperable. And the way that gRPC achieves this is by basing itself on standard technologies and standard protocols. And most prominently, the transport layer is using HTTP2, right? Anyone here actually use HTTP2 already? Quite a few. In your projects or on the browser? Yeah, yeah, on the project. Oh, fantastic, right? So you're using gRPC? Oh, fantastic. Well then, yeah, that's awesome. So HTTP2, why is that important? Well, first of all, HTTP2 is also a binary protocol, right? Rather than being able to telnet into, anyone done this, telnet into port 80 and say get / right, enter, and you're actually able to get a text response. With HTTP2, it's just binary. So all the get, the put, and all those methods are going to be encoded in binary, which is like 1 byte or so. The headers are being compressed as well. If you ever look into the actual content payload of a HTTP request, you're going to see there's tons of headers. And sometimes, if your message payload is slow, your header size is actually going to be bigger than the message size, right? So HTTP2 actually can compress the headers for you so that you can have efficient communication between the server and the client. Now, another really, really nice thing about gRPC is it bakes in streaming as a first-class citizen. Now, the way that we had to do this in HTTP1 is what? We kind of had to hack around the protocol a little bit to get that streaming-like behavior, right? With HTTP2, streaming is native. It's just you can multiplex multiple streams in a single connection. Okay, that's again something that HTTP1 cannot do. In HTTP1, you have to open up multiple connections to do multiple things. In HTTP2, a single connection can multiplex multiple streams that's coming from the server to the client, or even the other direction from the client to the server, and bidirectionally from the client to the server and server to the client. And just to compare and show you what that feels like, here's the demo page with HTTP2. And it kind of loads the HTTP1 image tiles. So all of these images are small, small tiles. And it's loading, I don't know how many tiles in to compose this image. So it's making these non-cacheable requests to via HTTP1. And if you run it on HTTP2, if I were to refresh this a little bit to have the connection set up, right? Here's the HTTP1. And if I run the test again, it's generally a lot faster on HTTP2 because of the binary protocol, the streaming. In fact, if your server knows what the client needs, you can actually stream that data to the client straightforwardly before the client even requests it. So you can also eliminate some extra hops there. Okay? So let's see what that feels like. And here's just a comparison, a chart. It's a nice chart. Somebody they wrote a blog on this, right? A comparison between gRPC and HTTP and JSON. Right now, I don't feel this is a fair comparison, to be honest, because binary protocols, of course, needs to be faster than REST, right? Than text ones, right? So it's obvious that it's going to be faster. But I think what's going to be more interesting here is per CPU. Per CPU throughput is many, many folds over a text-based throughput, right? And this is important. Why is that? Well, for two things. Number one, if you're running in a cloud-native environment, your resources are going to be CPU counts. And you want to be as efficient as you can per CPU. As a cloud provider, I want you to use your CPUs as efficiently as possible, right? Rather than saying just go buy more CPUs. No, no, no. Right? Make your app more efficient so you can use fewer CPUs. Now, the other thing, though, is that on mobile devices, they don't have as much CPU power, and your battery is going to be a concern. What gRPC will be able to work on the mobile device as well, and also being more efficient dealing with those situations. And look at the languages that we support for gRPC. Here's just a highlight of the primary languages: C++, Objective-C, Java, Go, C#, and all that. But if you focus on three of them, Objective-C, C#, and Java, these are the primary languages that people use to develop mobile applications, right? So it's fully supported on mobile, and you should definitely give it a try. So with that all being said, I'm done with my slides. Thank you very much. Just kidding, no. So let's see it. Let's see what it feels like, OK? So I'm going to be assuming a lot of people haven't seen this already. So I have a Bootstrap project here. I'm going to build two things. I got some time here, so I'm going to do a few things. The first thing I'm going to do is just a simple server, right? Rather than showing you how to write a RESTful server, right? It's easily done. I want to show you how to write a gRPC server, and then you can really compare and feel what this is like. Now, before I begin, though, before I write the server, the first thing I need to do is to create the IDL, the interface definition language. And the IDL for gRPC is based on protobuffer 3. So the first thing I need to do is to have this proto file, which is what I'm editing right now, this proto file. Okay? I need to set the syntax to proto 3. Okay? Very first thing I need to do. I need to set this proto file to using the proto 3 syntax. Then I can decide what package that this proto file and the content of this proto file belongs to, right? Just like Java, we have packages. Same thing here. I can say gRPC, and no, let's just do that. Okay, so that's my package. So whatever I generate from here is gonna be generated into that package. And then we have generator-specific options. So gRPC, to compile the IDL into the actual stubs, you need to run it through a generator. Okay, there's a PoloGen compiler. And the compiler can take in options. For different languages, you can have different options to set. So for example, for Java, by default, it's going to generate all of the generated stubs and the messages into a single giant Java file. Okay? And if you don't like that, that's OK. You can say Java multiple files is equal to true. What that will do is to tell the PoloGen compiler that rather than generating everything into a single giant file, which I personally don't like, generate each individual class into their own files, so I can see this clearly. Okay? And once you have this pre-set up, then you can start writing the service and the payload. Well, the first thing that we need to write is the actual payload. And in gRPC, you gotta define the request and you gotta define the responses, right? And rather than writing a class, well, we need to use the keyword message. And with message, we can say this is a hello world request. And that will correspond to actually a POJO code hello request with attributes and properties inside. Then I can, in this message, I can define what attributes I want to use. So for example, I can have first name, okay, and strongly typed. So every field, first name, for example, will have a type. But in addition to that, there's also a tag. A tag is the binary representation of this field in the payload. Okay, this is important. In REST, in JSON, for example, we use the actual string first name to identify this field. In gRPC and protobuffer, everything is binary, so we need a specific tag, a specific number to represent this field. Okay, so if the number is less than 16, that means it will just take a few bytes, right? A byte, actually. If the number is greater than that, then you'll expand. So the key here is if there's frequently used fields, right, that you just know it's going to be used everywhere a lot, then just use lower number tags, because then you're going to get a little bit more efficiency out of it, right? So I can do that. I can say last name is equal to 2. I think I have int64. Age is equal to 3. Not that I will live that long, but that's OK. And then we can actually do enums. In Java, we have enumeration, right? So for example, you can define an enum with selected choices. I can say sentiment. This is how good you are feeling right now. I feel pretty happy. I don't know about you, but I'm feeling pretty happy. So that's a 0, right? And you could be a little sleepy by now. I hope not. So sleepy is equal to 1. And at the end of this talk, you could be extremely angry at me for being here. So I'm going to say angry is equal to 2. Okay? And once you have defined the enum, you can say sentiment is equal to 4. Yeah, not bad. If you have a list of things, like an array list or some kind of thing that you have just a list, right? What you can do is rather than saying string, so you cannot do this, but if you want to define a list, you say repeated string hobbies, for example. And you can do that. And that will generate a list in the actual Java file. And finally, we can also do strongly typed maps. So you can have strongly typed key and strongly typed value. This is so nice. And I'm going to call this bag of tricks. Okay? And live coding is definitely not one of my bags of tricks here. So I hope everything works. All right? So as you can see, once you have defined this, the generated things will be interoperable across multiple languages. And if the language is type safe, right, this will actually generate the type safe payloads for you as well. Okay? So let's go ahead and define the response. Hello, response. I'm going to say greeting. is equal to 1. That's the response I'm going to get. Okay? And once I have the request and response, then I can actually define the service. Okay? So service is just with the keyword service, I can say greeting service, for example. And in this service, I can define my operations. And the keyword there to use is RPC. So for example, I can say RPC operation called greeting is going to take in a request and returns a response. Okay? And that's pretty much it. If I need to take advantage of streaming, so for example, if this is taking a streamed metrics, right? If you are taking IoT devices and IoT devices are streaming data to the server, well, we are streaming the request into the service. So all you need to do is to add string keyword, and this becomes a client to server-side streaming service. It will generate the stuff for you that can take in the string. Now, if you need to stream data from the server to the client, so for example, you said, I don't know, like the previous talk talks about reactive programming, right? You say, hey, just give me like 20,000 digits of pi continuously, 1 digit each. Well, you can just say string here. If you're building a chat application where you need bidirectional streaming, you just add string to both ends, and that's it. Okay, which I'll show you how to build after this basic demo first. Okay, so that's it. That's how you define the service. And then what you need to do is to be able to generate this stuff. Okay, so I have the IDO, but I need to then compile this into translating from IDO to the Java code. And to do that, in the past, what you needed to do was to figure out what type of operating system that you're running on, go find the right version of the proto-gen compiler, and then run this long, complicated command line, proto-c something -i, and then blah, 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 and then generate the Java code to the right directory. I didn't like that at all. That was in the past, right? So now, all you need to do is potentially go to GitHub. And let's go to gRPC and gRPC Java. Okay, this is the GitHub repository with all the code here. And if I zoom in a little bit, first of all, what you need to do is to define the dependencies. So let's do that. So dependencies. Okay. And then this is magic, right? How many people here use Maven, by the way? Okay. Oh, wow, majority of the room. Gralde? Oh, it's almost half and half. That's cool. So I'm sorry if you're using Maven. This is going to be looking like this, the entire block. If you're using Gralde, it's going to be looking like that instead. So depending on what you like to use, anyone using Ant? Just want to see. Yeah, there's always a few. There's always a few. I don't know if there's an Ant module for this, to be honest. But let's stick with Maven and Gralde for now. And let's see. So all I need to do is to add this build block here. What this is actually doing is to actually figure out what operating system you're using, and then downloading the actual proto-C compiler for your operating system, for your architecture, and then hook it up into the phases of your Maven build so that when you're doing the Maven compile, Maven package, it's actually going to generate the stub for you. Okay? So let's do that. So let me do a clean and package. I want to make sure this is new, right? OK, so I'm done with that. Clean and package. Oh, zoom in. And then in target, it generated source, right? So there's the source, and there's protobuf, and I can see gRPC Java. I can go all the way into the package, and here's my gRPC service, right? Now, I can also find the generated Java payloads. So it's also in gRPC, example gRPC. And here are the payload that you can use. Now, remember, I set the option to generate them into individual Java files. So this is what it looks like. If you don't have that option, everything will just be in one single Java file. Okay? Good so far? And now we can go ahead and implement the stub. So the first thing we need to do is to create a new class. Right? So I can say greeting service info. Let's now add it to the repo. And I'm going to zoom in here a little bit. The stub is already generated for you. All you have to do is to extend it. And it is called greeting service gRPC info base. So this is the base class you have to extend. And once you extend it, all you need to do is to override the gRPC operation that you have defined. Now, here's the interesting part, and actually some of the things that's really important as you go into this world of gRPC for Java. Look at the signature. Just pay attention to the signature. What we defined was what we call a unitary method, unitary operation. What that means is I'll give you one request, you give me one response. Now look at the signature. It looks a little bit different from what I expect, right? If I'm doing a unitary object request in Java, what do? Usually we do public hello response, right? Greeting, and then hello request. Oh, request. But that is not what's being generated. Okay? What's being generated is actually, I hate to say this, but it is somewhat reactive. It is actually a reactive asynchronous interface, right? When you look at it, you have an operation that takes in the request, but because it's an asynchronous operation by default, everything on the server side in gRPC is implemented as an synchronous operation by default. Okay? Whether you want to block or not is the decision of the client. This is important. The server is always designed to be asynchronous and scalable like that, and it's up to the client to decide whether they want to block or not. So in order for me to get the response back to the client, I need to code the response observer. Okay? So what I can do, for example, is for me to, rather than say return, I can say response observer and check out the interface here. It is reactive, right? Because if you look at reactive streams or reactive Java, you actually see very similar callbacks. There's onNext. That's where you send the data from the server to the client, or vice versa. And then when you're done, you call onCompleted. And if you have an exception, you call onArrow. Okay? Very straightforward. Just that they didn't name it reactive, observer or whatever. They made their own. It's called stream observer. So I can say observer onNext, and I can construct the response. Now another thing that you're going to notice in gRPC is everything they generated uses the builder pattern. Okay? So everything that you operate with gRPC uses builders. Okay? So here I need to create a new response. Rather than saying new hello response, I need to use a builder. And I can say build. Okay? And then I can set the greeting, and I can get the content from the request. And I can say get first name and plus, let me see, I'm just going to say hello in the front. Okay? Hello. And then I can also just print this out because we generate the toString for you, so you can easily kind of debug what's actually in the package. Okay? Now we're done. I say onNext, and the server is like, OK, I'm done. Well, not quite, because when you say onNext, we'll just send one payload to the client, but the string is still open. This request is not completed yet because this is an asynchronous interface. What you have to do explicitly is to call onCompleted. You have to code this. If you don't code this, even though in the definition we said it's only going to respond with one payload, but because it's an asynchronous interface, the client will actually keep the connection open until onCompleted is called. Okay? It's very possible for you to call onNext multiple times in a unitary response, but you don't want to do that. It's going to throw you a runtime exception, so you don't want to do that. But it's very possible to make that mistake in the API. Okay? So that's how we implement this service, and now we have to implement the server. Okay? So the server is what we need to kind of create ourselves to bootstrap the ports and then to respond to requests on our port, right? So rather than deploying this into your existing Tomcat or Jetty container, we actually have to use our own implementation of the server, which uses Netty underneath the thing, and that can actually deal with the HTTP2 protocol. It's not something that can be easily done today with the existing containers, right? So now I have to go back to that core bar code to figure out what I need to write here. I'm just kidding, no. So, so to write the server is pretty straightforward. All I need to do is to use the builder. Everything in gRPC uses builders. I say server builder, let me listen on port 8080, okay? And go ahead and build. And that's it. Okay, and whoa, here we go. And let me assign this to a variable of some sort. What is going on here? Variable. Give me the variable. No. There we go. I'm just going to click on this instead. All right. Introduce variable. There we go. Server. Okay. Now, when you're creating this new service, server, you also have to add or register the service here so that you register basically the handler to respond to this gRPC call, right? So I can do add service and new greeting service import, right? So you can do your dependency injection however you want, right? Create this instance of the service, and then you just pass it into this add service, and you're done. Now it's all registered. And then you can call service start. This will actually start listening on port 8080, right? And then you can wait because it's running the background thread, so if you don't wait for it, your main process is just going to quit, and your server will just die immediately. And you don't want that to happen, so you gotta wait for termination. Okay? So that is the server. That's it. Let's try to run it. How many people think this will work? Oh, wow. Wow, thank you. Oh, yeah, thank you. One person thinks this is going to work. That's great. Thank you so much. So let's see. So I got the server running. I'm going to do a clean install. I'm going to execute this main class. See, I love Java because it's type safe. I'm pretty sure I'm not going to get a runtime exception here. But no, this is actually working. This is actually working, just so you know. This is working because I didn't print anything out on the server startup. So this is actually running as a daemon. It's just waiting for connections. OK? Cool. So let's see what the client looks like. So if I go to the client here, I'm going to use a very simple client here. All this is going to do is to make the connection to the server, call the service, give it the payload, and get the request back. I want to print it out. So how do we do that? In REST, or if you use Spring, right, you use a REST template. Or if you're using Java, maybe straight up, just URL connections. Well, in gRPC, because we're using HTTP2 behind the scenes, and we have some abstraction layers in between, we don't want you to deal with the transport directly. So we hide everything, all the complexity behind the scenes, into a channel. So to build a channel, to get a channel to connect to the service that we just created, guess what do we use? We use a builder. So we can use the managed channel builder for address. So I'm going to connect to the local host. Whoa, not that. And on port 8080, right? And I can say build. Now, because I'm in a development environment, I need to use plain text. Now, I think all the Java developers know dealing with SSL sucks in Java. So I'm not going to deal with that right now. So I'm just going to use plain text for now, OK? And if you look this in more detail on how you can actually build a channel, there are a few things. The channel can actually manage the load balancing for you. This is client-side load balancing. Okay? So you can have a load balancer factory where you can decide on the load balancing strategy. So if you just want to do round robin, you can just use the standard simple round robin strategy that we already provided to you. However, you need to know where all of the services are. If you have 10 instances, where are those IP addresses? Well, to do that, you need to implement a name resolver. So this is given a logical name. Its job is to resolve multiple actual IP addresses for the server so that the channel can decide and know where to connect to. If there's a failure, it's going to move on to the next one and try, right? And I actually have a open source code on this where I actually connected the name resolver with Eureka. So if you're using Eureka for discovery, right, you can actually use Eureka to look up the logical name, get back the client or the server IP addresses list, and you can convert that into whatever that gRPC expects. And then now you have client-side load balancing in gRPC. Okay? Now, once we have this, there's something wrong with my IntelliJ, but I'm going to click on this every day now. So introduce, and I'm going to say channel right here. Okay? Once you have established this connection, or this is actually defining what that connection should look like, what you need to then do is to give this connection to the stub. Okay? So to do that, I can just look up the generated code, gRPC service, and then check this out. And then we can generate and create the instances of the client-side stub. And if you look at the client-side stub carefully, it gives you 3 options. This is nice. Remember what I said about the service on the server side? Everything on the server side is synchronous, right? But it's up to the client to decide whether they want to block or not. So here, the client has options. You can create a fully async stub, which you can listen to the stream observer callback. Or you can use a future stub, which you can use the future to get back and wait for the result. Or you can use the blocking stub. Then you just block the code until the data is being returned. So I'm going to use the blocking stub for now. OK? And that should do it. There we go. That works. I'm going to call it stub. And I can make the code. So I can say stub dot greeting. Everything's generated for me. I never have to write client libraries ever again. How awesome is that? How many people here write your own client libraries to talk with RESTful services? Yeah? Yeah, quite a few. Yeah? Did you ever miss a field or make a typo? Not here, not the types. The types are going to be all baked in here. So I can go and create a hello, not hell, hello, request, new builder, and build. OK? That would be straightforward. I can set my first name. I'm going to say I'm Ray. Set my age. I'm just say I'm 18. I can add hobbies, right? So everything that we put into that profile as a list, I can just add hobbies, right? I like photography, so let me do that. And I can also, I like to travel, which is great. To set that map, rather than getting the map back, we just generate the methods for you. So you can put an entry like live coding. Not very good. OK, so right, so now I can generate this payload, and I can make this request. And what can I then do is to get back the response. Oh, where's that key? Oh, it doesn't like me. All right, so I'm going to go here. I'm going to zoom out. I'm going to click on this thing and response. Yay. And then I can print this out. If I can only spell print line response. OK, cool. I think that's it. You think that's it? It's pretty straightforward. It's pretty easy. And I'm going to do another poll. How many people think this will work? Oh, wow. Even after the first try, just a little bit more people. All right, fair enough. Let's try it. So let's try. Oh, that's from before. That worked before, but I'm going to do a real one now. So I'm going to do a clean and package and execute. Right, there's no cheating here. And there you go. So they actually connect to the server, right, make this gRPC request. And I took the long way about this, right, because I want to show you exactly what goes on in every step. But if you start to do this, you can write a new service very, very quickly. And you can start consuming it very quickly as well. Now, if I go to the server side, remember we said we implemented toString. So all of the things I put in here can just be outputted on standard out if I want to, or you can log it if you want to very, very easily. OK? Good so far? Yeah? Well, but that was too easy. That was way too easy because it's just a simple request and response. What I want really to show is the power of gRPC when you actually take advantage of streaming. OK? And this is cool. Remember, I said you can stream from server to the client, client to the server, and you can do bidirectional. So to demonstrate that, I will show you how to build a chat application with gRPC. And the very first thing you need to do when you build any gRPC application is you got to define the proto file. Okay, so here I have a chat.proto. Okay, and here I define the service, and I define the payload. There's a chat message, which is what the client sends to the server, and I define a different payload for the server to the client, just so I can differentiate between the two easily. You don't have to do that. And then I define the service. And to make this bidirectional streaming, I just need to add the stream keyword to the request and the stream keyword to the response, and that's it. Now, if you notice carefully here, there are actually other proto files that we created that you can simply import. These are like classes or packages you can import into your Java application. We actually have additional proto files with well-defined types that you can just import into your existing payload. So in this case, I'm importing a timestamp type from another proto file, and then you can reference, you can strongly type that and reference to it in your own payload as well. And there's a range of these different types that you can import. Okay? So let's go ahead and implement this. This is a bidirectional streaming service. And this is actually the stub that we generate. Okay? So the stub, the method is called chat, right? And remember how we need to send the data back to the client from the server side? We need to use a stream observer. And this is another thing you have to watch out for, because you have the return type of stream observer. You also have the request parameter called stream observer. And this is where I get lost sometimes, right? This is important for you to remember. The thing in the request here, the observer here, is what the server needs to send to the client. I got lost here again, because then the return type is actually what the client sent to the server. Okay, this is a little counterintuitive. You're returning an object that is actually getting data from the client to the server rather than sending the data back from the server to the client. Okay, that's important. So I'll show you why this is done this way. So first of all, for the server to listen to the incoming messages in a string, it needs to listen from a listener, a callback, right? So this stream observer I'm going to return is literally the implementation of that callback, so that the client can, when the client sends to the server, I can listen to it, right? So this stream observer, this instance, when the client sends something to the server, this onNext method will be called. And this is where I am receiving, receiving the data from client to the server. And when I receive a chat message, what I want to do, I want to send it to all of the existing connections that I have so far on this particular server. So I already register all of the existing connections, right, in this observer list. So what I can do is I can then propagate the message to everyone. So I can open a string, and I can do for each of the existing connections. Let me go ahead and send the message to them. So I'm going to say, on next. So this is opening up all the connections that the client established to us. I'm going to send data stream to the client. Okay? And this thing, I need to create a chat message from server. So I'm going to say MSG. Okay? And chat message from server. .new builder. I need to use builder everywhere here. And I need to click on this every day now. That's weird. Okay? So I'm going to code this MSG. Okay? And I can set the actual message payload to what I receive from client. Okay, that's the first thing I need to do. All right. So now I receive one message. I'm going to broadcast it to everyone who is connected to me. And then I can handle errors. If there's an error that's coming from the client, if you caught something, I do what all the good Java developers do. We do nothing. All right. No, just kidding. Don't do that. In this case, I want to remove my connection so that they don't send me the data payload anymore. And if I'm completed, I do the same thing. And I return this, close this loop, and close this block, and I'm done. And that is a streaming service, bidirectionally. I'm receiving something, I'm sending something out to everybody else. Okay? So far, so good? Let's run the server. Let's clean out. Let's run this and see if that works. Any compilation errors? No? Okay. Good. Bidirectional streaming. Done. Okay? Or I'm done. I don't want to show you the other side because it's harder. I'm just kidding, no. You'll never find out if this is actually working, would you? Now, to prove to you this actually works, what I need to do is to implement the client. And what I have done is to create a JavaFX application. Wait a second. Is that? Yes. Yeah, that's it. So here's the JavaFX application. I'm going to just package it a little bit. I'll show you what it looks like. So it's nothing special here. You can say Ray. You can say hello world. And when you click on send, nothing happens because this is not connected to gRPC yet. Okay? If it actually worked, then I will be cheating. I will be lying to you. So this is not working right now, which is good. Okay? So what I'm going to do is to actually implement it. And hopefully you'll see how easy it is to do this. So I have done already the bootstrapping with the UI. You know the channels. This is how I'm going to connect to my service. And here I'm creating a new stub. This is actually an asynchronous stub. This is fully asynchronous, right? And for me to call the service, chat service, I say chat. Now here's where things get a little messy again, because this method expects a stream observer. Okay. Now you have to remember what does this actually do. This is actually a listener listening to messages coming from the server to the client. Now, okay? This is a callback interface that we're implementing so we can receive data from the server. And to implement this, for example, I can say I want to display this in the UI. So I can do something like run later. And can add a message to my list of messages in JavaFX. So I can say add. And what does this message need to look like? I'm going to say string format. Ooh, string format. What am I going to do here? I'm going to have the name and colon with the actual payload. And then I can get the name from the message. So chat message from the server, get message.get name, get from, I think, yeah. And then I can do chat message from the server, get message.get. This is just how I name my things. Please don't mind this. When you do this yourself, it wouldn't be that complicated, all right? And then I need to find the builder in the right place. Where is that builder? Oh, no, that's it. No builder necessary. OK, good. My head is wrapped around builder in the past couple of weeks. So anyways, so now I can receive the message from the server. I add it to JavaFX, add it to the payload of messages, and that's great. If I receive an error here, you know what I'm going to do? Do nothing. All right. And I mean, if anything, you should, print the stack trace. You know what I mean? Like, just don't ever swallow or hide your exceptions ever. All right? So here, uncompleted, I'm going to do nothing as well. All right, good, and that's it. But how the hell do I send data to the server? This is only receiving. How do I send data to my service? Well, if you look here carefully in chat, it's actually going to return you a stream observer. So everything here is based on strings. So this observer is what you need to use to send data to the service. So to server. Okay. So whenever I hit that send button, I need to send a payload, stream it to the service. And to do that, I need to use this callback to server. I can call onNext, right? And this is which is generate a payload, establish the connection for us, and I can say chat message, new builder. I can build. And I can set the from with the name.getText, right? I can set the message with message.getText. And that should be it. Now I have bidirectional streaming all hooked up with gRPC with 2 strings, right? One to the server, one coming from the server, and I'm done. But I only wanted to do this if I click on the send button. So I need to say action, right? When somebody click on that button, this is what I'm going to do. So for DD and boom, done. OK. Whew. I think I'm done. Now, if you want to do another try, how many people think this will work just off the bat? Wow, even less. Holy, wow, this is bad. This is bad. Why? Why is that? Am I that bad? It usually grows a little bit. It never go backwards, just so you know. But then it's live coding, so I have no idea myself either. So we'll find out pretty soon. So here's the same app. I'm going to say Ray and hello, the Vox. This is the scary part. And yes, it worked. Woohoo! Yeah, not bad. But that's only with one client. That's only with one client. And I'm going to run another instance of it. So just to show you how this actually works behind the scenes, right? Now I got 2 clients. Let me zoom in. And I'm just going to be my boss. My boss's name is Greg. I'm going to be like Greg and say, hey, Ray, good job. Yeah, I can actually see it well. Well then, why? Thank you, Greg. Awesome manager. Yeah. Now I can do this all day, chatting with myself, complimenting myself, but I don't want to do that, right? So you can see, you can build a bidirectional streaming service fairly easily with just a few lines of code. Now, of course, I did it slower, much slower and slowly, to talk through all the details behind it. And so you can feel what it is like to use gRPC. And hopefully, it is pretty straightforward. There's nothing too much to it. We made the experience pretty good. The only things you got to remember is everything is a stream. You have to deal with the stream observers. Now, there are actually ways, talk to me afterwards, there are ways for me to tie this into reactive Java or Rx. I can tie this into observable from Rx. Then you can do some of these things in a more streaming fashion that you're more accustomed to, right? We can also do much more. Let me see if I have this slide. Let me go back. There we go. So we saw the streaming. Another really cool thing is, imagine if you have a backend service that's taking in from the client, like a search request. Like some big company that I know does this, right? They're taking a search request, OK? I don't know which company, but they do. Right? They have a query, you say search. And then we go through multiple backend services. We need to do many things in parallel. But imagine if one of these services just takes forever to respond. Do we want to wait for it? Is it that important to wait for that one single response? Maybe not. So what you can do in your microservices deployment is that you can also set something that we do, which is setting a deadline. How quickly or how long should I wait for my services to respond the payload to me? And this deadline can be propagated through the multiple layers of the nested services code across server boundary. This is cool. So you can say the top service only has 1 second to respond. And then the second service took half a second. And the subsequent service took more than half a second. And this entire thing is invalid now because it took more than a second. It's going to propagate this deadline all the way down to the last call. And then you can cancel a call. You have a callback to handle the cancellation as well. You can add interceptors. You can propagate data. So imagine if you have a JWT token or some authentication token you have to pass along the way through every layers of the service. You can hand it off in a metadata in the context. I just heard this from someone yesterday from the community, right? They're doing mutual TLS, mutual secure TLS across multiple services, which is super, super awesome to do. And you can actually do that in gRPC as well. A lot more to it. If you're interested, please let me know. There are many, many patterns we can implement from the microservices architectural concerns. You can translate that into gRPC pretty straightforwardly. And lastly, if you want to find the code, you can go see my GitHub at Satanism on the gRPC Java demos. If you want to learn more about gRPC, go to gRPC.io. And one of the reasons I'm here is I want to excite the community. I want you to try it. And I also want to hear your feedback. So the best way to do that is to come to the RSC or find us on Twitter. And also, if you can, please contribute. And you can find out how on the link on the top. So thank you very much for your time. And yeah, it's great to be here. Thank you. Any questions? Questions? Yes, question over there. Yeah. So that's a great question. So the streaming server side, which is client servers here. This one, right? Let me think here. You probably don't need to. Yeah, you just need to make sure it's thread safe, if that's the case, if you want to share that instance. Yeah, I'm just so much, yeah, it's easy for me to just type one in and generate the code from the scratch. Yeah, but no, you can try to, say, have a listener that you can share, but then you got to be sure it's type safe, though. Yeah. OK, anyone else? Any other questions? Yes, question in the back. Yeah. Yeah. Got it. So the question is, if you want to add a new attribute or a new property to this payload, what do I need to do? Do I edit the generate code, or do I edit the IDL? The answer is always edit the IDL. You never want to touch the generated code, because the generated code could be overwritten, it could be updated. You just don't want to deal with that. But one thing I forgot to mention is the proto buffer thing is actually backwards compatible when you define a payload. So what that means is you can always add new fields, as long as you don't reuse the existing tags, right? Because the tag is actually the name that uniquely identify where in this payload this data should belong to, right? So if you want to add a new payload here, I can say string, I don't know, rating. Let me say rating, right, is equal to 7. And I can make an enum. You can have poor and very poor, right? So I can have that, and I can add this field. And it's not going to affect the client that's already using the existing protobuf, OK? That's consuming it. You don't actually break them. If you need to delete a field, you can also do that. You just remove that tag, right? You can reserve. There's a keyword called reserve. I think it's reserve just 1 or something. There's a keyword called reserve. So you can reserve that tag so nobody ever uses it again. And then you can define a new tag if you want to. And because the ID is still there, it's being reserved, whoever is using it can still communicate with the server. It's just the server doesn't see it anymore, right? So there's no breakage in the client, but the server doesn't see what it's expecting. But that's fine. You'll just handle it that way. So you can do both ways. Every time you do, yes. So every time, and that is how we define this in the POM, right? So the question is, every time I update this IDL, and if I do a package or whatnot, do we regenerate the IDL? And it's completely based on Maven in this case, because we're tied into the compile phase. So every time compile phase is being triggered, it will try to regenerate it, right? If you want to do this manually, having more control, you can get rid of this binding. So you can always just generate at your own time. Okay. So I think that's it. Oh, yes, one last question. Yeah. Oh, I see. Are the interface automatically versioned? I had to say this, but no, it's not. As far as I know, it's not automatically versioned. They do try to make sure that whenever we generate the stubs, we don't break your existing code. So rather than implementing an interface, they have this import base. So if you don't override a new method that you just added to the service, it will respond with a default response, which is an error, and the client would just have to handle that. Yeah. Okay, cool. So thank you so much for your time. If you have any other questions, just come up and or come to the Google booth, and we'll be happy to chat. Okay, thank you.